We're going to be looking at a square in this problem. We're asked to find the side of a square whose diagonal is 5 feet longer than a side. And in this case, we'll be looking for the length of a side of a square when they ask us to find the side of a square. The first step in our problem-solving process will be to familiarize ourselves with the situation. And we can do this by drawing a picture. Whenever you have a problem that deals with geometry, it's a good idea to draw the picture that you see, and we know we're dealing with a square. So I will sketch a square. What we're told about the square is that the diagonal is 5 feet longer than a side. And here's the diagonal here. Now we're asked to find the length of a side, so let's label that S. And since a side is S, the diagonal has to be S plus 5. Now since we're dealing with a square, all the sides are S, so I could actually label them all S. And then we look and see what we have here. Well, we have a square, but inside the square we have a couple of triangles. Since a square has right angles, we also have right triangles. And whenever you see a right triangle, one of the first things that should pop into your mind is the Pythagorean theorem. And that's what we're going to use to solve this. When we translate to an equation, we're going to use the Pythagorean equation that says a squared plus b squared equals c squared. All right, that a squared plus b squared equals c squared. This is true for any right triangle. A and b are the legs of the right triangle, and c is the hypotenuse. Well, in this case, a and b have length s. So I can write s squared plus s squared. Since c is the hypotenuse, it has length s plus 5. So I write s plus 5 squared. And I have an equation that I can solve. And I'll solve that on another piece of paper. The equation is s squared plus s squared equals s plus 5 squared. I can combine terms and I get 2s squared on this side. And I multiply this and I have s squared plus 2 times s times 5, or 10s, plus 5 squared, 25. I use the rule for squaring a binomial. I want to get a 0 on one side, so I subtract s squared from both sides. I subtract 10s from both sides, and I'm going to subtract 25 from both sides. 2s squared minus s squared gives me s squared. Then I have minus 10s minus 25. And on this side, since I subtracted everything, on the right side I'll have 0. Now this has a 25 and a 10 in it, and it might look like it can factor, but if you try to factor it, we're not able to factor this. So we'll have to use the quadratic formula. The quadratic formula states that in this case the variable is s. S is going to equal the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And here a is 1 because s squared is 1 times s squared. B is negative 10 from the negative 10s. And c is negative 25 from the remaining term. So substituting in here, I have s equals the opposite of b, that's the opposite of negative 10, plus or minus the square root of b squared, which is negative 10 squared, minus 4 times a times c, all over 2 times a, or 2 times 1. So s equals the opposite of negative 10 is 10, plus or minus the square root of negative 10 squared is 100, minus 4 times 1 times negative 25 is negative 100. And that's all over 2. Now I can simplify inside the radical sign. So I have s equals 10 plus or minus the square root of 100 minus negative 100. is 100 plus 100, which is 200. All that over 2. Now I can simplify further because I can simplify the square root of 200. And I do that. I'll copy what I have. I had s equals 10 plus or minus the square root of 200 over 2. Since 200 is 100 times 2, written like this, 10 plus or minus the square root of 100 times 2 over 2, I can simplify by taking the square root of 100 times the square root of 2, and the square root of 100 is 10. So I write s equals 10 plus or minus the square root of 100, which is 10, times the square root of 2. And all that is over 2. Now, since I can factor a 2 out of both the 10 here and the 10 here, I will be able to simplify again. I can write that as 2 times 5 plus or minus, and here the plus or minus sign works just like a plus sign or a minus sign would. 5, I factored a 2 out of this term and out of this term, and all that's divided by 2. And now since the the numerator, the top expression, is factored, I can cancel factors of 2 in the numerator and 2 in the denominator. Don't attempt to do this until you can factor the numerator. 2 over 2 is 1, so I have s equals 5 plus or minus 5 times the square root of 2. So we actually have two answers to check, 5 plus 5 times the square root of 2 and 5 minus 5 times the square root of 2. When we check those answers, since we're dealing with sides of a square, let's first see if either of them is negative, because if it's negative, we know that it can't be a possible answer. 5 is positive, 5 times the square root of 2 is positive, so their sum will be positive. What about a subtraction? Well, I subtract something from 5. If 5 times the square root of 2 is a larger number than 5, then this difference will be negative. 5 times the square root of 2 is 5 times something greater than 1. So 5 times the square root of 2 will be greater than 5, and the difference will be negative. If it's not obvious, you could take a calculator and estimate this, and you would also find that it's negative. So that is not a possible solution. Now we need to check this, and to check it, let's draw our square again and just see what we have. We have a square, and we have the sides are 5 plus 5 times the square root of 2. The diagonal, remember, was 5 more than the side, so the diagonal would be 5 plus this, or 10 plus 5 times the square root of 2. Again, remember we have a right triangle here, and this side would also be 5 plus 5 times the square root of 2. So we can use the Pythagorean equation, a squared plus b squared equals c squared, and see if this squared plus this squared does equal the diagonal squared. We'd write that as a is the first side, so that would be 5 plus 5 times the square root of 2 squared, plus the other side will be just like that, 5 plus 5 times the square root of 2 squared. And we're asked to, we want to know if that equals c squared, where c is 10 plus 5 times the square root of 2. So we're asked to know if that's that squared. We'll work these out separately. We have, I'm going to square a binomial. We have 25 plus 2 times 5 times 5 times the square root of 2, which is 50 square root of 2, plus 5 times the square root of 2 squared, which would be 25 times 2, or 50. Plus, since this is the same thing as this, I'll just copy. 25 plus 50 times the square root of 2 plus 50. And I want to know if that equals this. Squaring this, I have 10 squared, which is 100, plus 2 times 10 times 5 times the square root of 2. 2 times 10 is 20. 20 times 5 is 100. So I have 100 square root of 2 plus 5 times the square root of 2 squared, which again is 25 times 2, or 50. Now I'm going to simplify both sides. I'm going to combine like terms. I have 25 plus 50, which is 75, plus 25, which is 100, plus 50, which is 150. Plus, I have 2 50 square root of 2. 50 square root of 2 plus 50 square root of 2, which is 100 square root of 2. And this side I have 100 plus 50, which is 150, plus 100 square root of 2. These are exactly the same. They are equal, so this does check. And we have a solution, and we can state then, using the correct units, that the length of a side of the square is 5 plus 5 times the square root of 2 feet.